Welcome back to the 7 Caillou series. This one's called Simple Fun Number 2, Circle of Numbers. Your task, consider integer numbers from 0 to n minus 1 written down along the circle in such a way that the distance between any two neighboring numbers is equal. Note that 0 and n minus 1 are neighboring too. So I'll scroll down to the diagram. 0 goes around like a clock does, comes to 9, and then back to 0. So n would equal 10, right? 0 to n minus 1. Okay. Given n and a first number value, check out over here in our method stub. We've got that n, first number, and while I'm here, I'm going to lowercase that. It's just a common convention for parameter names and methods. Find the number which is written in the radially opposite position to first number. So let's look at that example again to make this make sense. We know n equals 10. So in this case, imagine they give us n equals 10 and first number equals 2. Notice they want 7 because if you go straight across the circle, to make a diameter, that's what they mean opposite. Because right, if I went from 2 to 6, that wouldn't be the diameter, right? And same if I went from 2 to any of the other points. There's one point that's where you go across and you form a diameter. And that output should be 7 in this case. And I think that's pretty clear from the picture. Input output, okay, they give us some constraints. They tell you n's between 4 and 1,000, a positive even integer for n. Feel free to error check that stuff if you like. Okay, I'll get into it. Go ahead and pause the video, try this one out. I know it's a little more on the mathy side than the coding side, but it's good for you. Okay, so the way I broke this problem down is I first want to take n, which is the number of points, right? And I'm going to work in degrees. That's easy for me to think about. So we know that a circle has 360 degrees. And so I'm going to make this variable, let's call it degrees per point. And all I'm trying to say here is I want to know the number of degrees that are formed. Imagine I had a center point here, right? And you had radiuses going to 1 and 2. And then I'm just talking about the angle formed between those two radii, excuse me. So that's sort of the idea, the first step. I just want to get that value. And so since there are 360 degrees in a circle, I'm going to divide that by n, in this case 10, right? So in our example, there's 36 degrees between each of these points, okay? And then the idea is that when they give me the first number, I'm going to start from 0. Let's say they give us 2, just like in this example, right? Then I know there's 36 degrees per segment here, so I just add them up. I multiply that value by the first number. So if it's 2, I multiply it by 2. Degrees per point in our case, we said was 36. Multiply that by 2 and you get to 72 degrees. I'm thinking of this as the 72 degree mark. And then the idea is that I can go halfway around the circle. I'll add 180 degrees, right? That's half of 160. That's how you get the opposite side. And then I'll sort of divide back by the degrees per point to get this numerical value of the point. So let's proceed a little bit. We have our degrees per point, and then let's make another one. I should note too that I set this up as a float, right? Because integers, they may not come out evenly when I divide, right? If I divided 360 by 17 or something, it might come out with a fractional part, and I don't want to throw away. Remember, if you do integer division, it'll truncate, it'll just throw out that fractional part. I don't want to do that until the end. It says I need an integer value, and so I'll get that at the end, but I don't want to lose my precision in the meanwhile. So good. So we got degrees per point. Next, we'll calculate the degrees to the first first number, as they're calling it. So let's call it degree to first, or whatever you like. And we know that's the degrees per point, 36, and you just multiply it by the first number, right? So that gets us to that 72 that I was talking about, 36 plus 36, or 36 times 2. So we know the degrees represented here. Okay, next we want to jump across the circle, and I do that by adding 180 degrees. So I could say degrees to opposite. Wow, my spelling's awesome today. Degrees to opposite. Okay, so that would be like degrees to first plus 180. And now I set this up in parentheses because I want to go modulo 360 degrees, right? Because imagine I added 180 to 300, for example, and then I get 480 degrees. Well, when we talk about angles, we usually do it in the range between 0 and 360. So you could think of it just like as a reduced form. When I divide by 360 and take the remainder, it's just setting that degree value within the initial range. It's just like with fractions, how we reduce too, right? You don't say 4/10. You can, it's still right. We just usually reduce it and say 2/5 when you want to give a proper answer. And I'm assuming that their tests are going to check for reduced. Well, actually it won't matter because we're going to the number representation. But anyway, that's why I did modulo 360. I like my angles in reduced form. Okay, good. So now finally, to convert back, we've got the degree value representing 7, but we don't want that degree value, right? We want the number 7. So we've got to get back to that. To get there, I'm going to say degrees to opposite. And I'm going to divide that by the degrees per point, right? Divide it by that 36 value, the angle set up there, divided by 36, should give me the number of segments to get there, right? And so the final thing is that we need this in integer form. So I can do something like this. I can use a C style cast. And let's see what happens when I do this. Okay, green, but show us the whole story. And we got a lot of good stuff going on here, but whoa. Look at these failed tests. So close, right? Expected 59 was 58. Was that it? Was there just one? But it very much feels like there's a rounding problem, right? Like we basically got the right answer, and you can imagine we're working in floats and we eventually convert to an integer, and it really gives that feeling that yeah, like we're just dealing with a rounding thing. And so how I got around that was that I actually rounded the values. I just used math round by default, and that got us where we need to be. If you remember, we used math round in another video where the default rounding mechanism wasn't quite what we needed. It worked here, so I wasn't going to rock the boat. But just know that rounding doesn't always get you where you want to be either. So as a refresher, we looked at that midpoint rounding, because note, if you just pass the double in like we did, double precision value, it rounds to the nearest integral value, okay, yeah, and rounds midpoint values to the nearest even number, which may not be what you want. It works here, so I was going to leave it. I think in the other video we went to midpoint rounding and we wanted the away from 0 one. Remember, there was, yeah, away from 0. That worked for us in that situation. So if you're using math round and it seems like it's not rounding correctly, I just wanted to refresh your memory that there are different rounding strategies that you can use. You don't have to just abandon ship on that. But anyways, it worked here for me, so I'll keep it like that. I don't have any comments or anything to clean up. I'll probably just submit mine like this. I broke it out into steps, but you can imagine that you could insert this part anywhere degrees per point is used, right? So you could write this out as one equation if you want. I'm not that bent on having the one-line solutions. I try to do this in a way that's stepwise where you can easily follow along. But feel free to refactor yours if you want to condense it. I was trying to use good variable names that make it clear what I'm trying to do. So I think that's enough said about that problem. I will take my points, please. And then, yeah, you know, come on, one-liner Wallies, you know, they're all over this. So yeah, learn from them too. See if there's anything you can learn from some of these other solutions. Good stuff. As usual, hit me up with your questions, comments, concerns. Otherwise, we'll keep rolling, cranking out challenges. Thanks for watching.